In this video, we're going to talk about how to graph a tangent function. So let's start by just looking at what this function looks like to begin with. Here I have a picture of the tangent function, and I want you to notice that this function reminds me a lot of what a cubic function would look like, in that it's an increasing function. It's going to come up, it's going to cross the x-axis at some point, and then continue on in the y, or the positive y direction. And you can see here by these green lines that I have, each of the green lines is the tangent function. You can see that these green lines fall in between the blue dotted lines, which would be the asymptotes. Okay, so it's going to be a repetitive or a periodic, again, function in that it's going to be repeating. And some of the properties that we can find from tangent are that the domain of this function, remember that domain are the possible x values, so the domain of the function would fall in between the asymptotes. So everywhere that I have an asymptote crossing a vertical asymptote that crosses the x-axis would be kind of like in between what my domain would include. Then the range of the function would be the possible y values. Notice that my function is going to come up from the negative y, cross, and move on into positive y. So in other words, the range of the function would be from negative to positive infinity. Now, unlike our sine and cosine functions, which had a period of 2 pi, meaning that one complete picture for both of those functions occurred between 0 and 2 pi, the tangent function has a period of just pi. So since the graph is shifted, it appears to be shifted, in other words, it's hard to recognize this right off the bat. But if we were to, let's go in and let's just label this. If I know that this is crossing the y-axis at pi, then this point to the left over here, I'm going to label that as pi over 2, and this point to the right of that would be 3 pi over 2. So for one complete picture of tangent to occur, meaning I'm going to come up, cross, and keep going in that direction, this all occurs in a period of pi. So if I were to take 3 pi over 2 and subtract pi over 2, you could see that that is occurring. One period is pi. Okay. Vertical asymptotes occur at odd multiples of pi over 2. So here I have 1 pi over 2, 3 pi over 2. I could move back and go negative pi over 2, negative 3 pi over 2. Okay, and that would just be a pattern that you would notice. And the last property we want to kind of distinguish here is that there is no designated amplitude. Think of amplitude as the maximum height or minimum that our function could occur at, and since my functions move off into the negative and positive y direction, there is no height, there is no maximum height, and there is no minimum. We are going to use amplitude, however, to just be able to graph, put some points on our graph. Okay, so let's go into the steps for graphing the function. We're going to first determine what the period of the function is, and tangent is different. Again, the period of tangent is going to be determined by pi over b. So since my period is a pi, then to determine my period when I graph it, we would divide it by whatever b is. Then we're going to go in and we're going to locate the two asymptotes on either side of my function that I'm graphing. And for tangent, we find that by solving these two equations right here. So I'm going to solve it for both a negative and a positive value. And I'm solving for x. In other words, I'm solving to figure out where the vertical asymptote is crossing the x-axis at on the left of my intercept and on the right of my intercept. And then based on that, we're going to divide the interval up into just two parts this time. Label both the x and the y axis using the interval here and a. Draw the asymptotes and then sketch the curve. So those are the steps that we're going to follow to be able to graph tangent functions. So let's practice that on this first one. Here I'm being asked to graph y is equal to tan of 2x, and I'm going to do this over 3 periods. So the first thing that I want to do is figure out what the period is. Okay, so step number 1 for me is going to determine what is the period, and I can do that by figuring out what b is. So here, b again is the coefficient next to the variable x. So in this case, b is 2. Therefore, the period, which is given by pi over b, would be pi over 2. Okay, so now I know I have a period. In other words, I just shrank my my picture down, so I have one complete picture occurring in a pi over 2 manner. The second thing I want to do is figure out what the asymptotes are. The asymptotes come from the two equations that I would need to solve here. They are set up as bx is equal to negative pi over 2, bx is equal to positive pi over 2, and it's always bx equals negative and positive pi over 2. Now I'm going to solve for x. I already know what b is, so I'm going to plug in 2 for b, and I say, okay, 2x is negative pi over 2 and positive pi over 2. And solving for x, so I'm trying to solve for the where this is crossing, where the asymptote crosses the x-axis. So in other words, I can divide both sides by 2 or multiply by 1/2, and I end up with negative pi over 4 and positive pi over 4. Okay, so these are the vertical asymptotes that are occurring on my function. The other thing I just want to be able to write on my graph is I want to be able to give the a y value, and although I don't necessarily have an amplitude, I'm still going to mark the positive 1 and negative 1 on my graph. So let's go through here, and we're going to set up the graph using my asymptotes. So we're going to come in here, draw the graph like this. I know that these are one set of intervals that I'm going to mark on my graph. So I'm going to come and I'm going to put a negative and a positive pi over 4. And at those points, I have vertical asymptotes. Now, in my original question, and one more thing, I want to also, if these are my two asymptotes, midway in between that is where my tangent function is actually going to cross the x-axis, which is why I only have to figure out, which is why I only have to divide this interval up into 2 parts. So in other words, I need to figure out what the midway point is between negative and positive pi over 4, and that one's pretty straightforward, it's just 0. Now, what the instructions were asking me to do is to do this for 3 periods, which means I have one picture here and I need to draw 2 more pictures. So I can go in the positive direction, and we need to remember that for this particular function, I would have one picture, another picture occurring at pi over, if I were to add pi over 2 to each of these endpoints, or each of my asymptotes, I should say. So if I take pi over 4, or 1/4, and I add one complete period, which is pi over 2 in this case, so that would be 1/4 plus 1/2, that's going to give me 3/4, or 3 pi over 4. Okay, and I know that I'm going to have one more set of asymptotes occurring there. Now halfway between 1/4 and 3/4 is pi over 2. Okay, so this would be one picture, this is 2 pictures, and I'm going to move, just to try it out, I'm going to move in the negative direction also. So if I were to move this way from my asymptote here, I'm going to, from a negative pi over 4, I'm going to add pi over 2, okay, because that's moving, because that is a period in the negative direction, and we end up with negative 3 pi over 4. Draw one more set of asymptotes, label my x-intercept right here at negative pi over 2, and I have my graph divided up like I need it. The other thing that I want to draw on my graph is just a point representing this number over here, so 1 and negative 1, just to give me a general idea of what's going on, because I'm not really concerned with getting all of the points. I just want to have a general idea of what this picture would look like. So my tangent function is going to come up from the negative, cross at the midpoint, and continue on in the positive. And it repeats that because it's a periodic function. Cross and move. It comes up, cross, and move. So as long as you can get the asymptotes, the x-intercept, where, in other words, where the tangent function crosses the x-axis at, as well as giving me a general idea of these numbers right here, and that it's moving, that you have the general shape correct, in other words, that it would be increasing from left to right, then you have what I need you to do as far as graphing a tangent function.